All right, so the set of rules I'm going to show you today, I have a name. It was these rules were developed by two folks, Denevitt and Hartenberg, and for that reason they're called the Denevitt-Hartenberg parameters. Okay, that's a lot of writing, so from now on we're just going to call it DH. Okay. Okay, so let's get down to the rules. So I'm going to show you these rules. Okay. And then later in the course, I'm going to try to convince you to throw out these rules. Okay, because we have something better. Okay, but we'll get to that later. Okay, so we need to draw a picture. This has to be a fairly detailed picture, so I'm going to do my best to draw it carefully. Okay, so here's one joint. Here is another joint. Okay, so let's call this joint I minus 1. And this is joint I. Okay, and there's some link that connects these joints. Okay, now I want to assign a frame to this link. Okay, so when you think assign a frame to a link, usually you think find some point on the link, boom, attach it. Okay, well that's not quite how it works here. Okay, so here's our rule. First thing we're going to do is we're going to find the joint axes. Okay, so here's the joint axis. Here's joint axis I. Okay, now what we're going to do is we're going to draw a line from this axis to this axis. Okay, and this line has to be perpendicular to both. Perpendicular here and also perpendicular there. Okay, so that's the first thing. Now, you might say, well, what if the lines are parallel, or what if the lines intersect? What do you do? Okay, don't make it complicated now. Just pretend that there's some unique line, okay, that connects these two joint axes, okay, such that they're both perpendicular to both axes. Okay, so we do that. Okay, once we find that line, then here's how we attach the frame. So the origin of link frame I minus 1 is going to be here. Okay, and we're going to define the z-axis to be in the joint axis direction. Okay, so joint axis here could be this way, could be this way. Okay, so here again, there's no, some people think it's important to always specify the one direction. Other people say, it doesn't matter, right? Anyway, so let's say we define it such that it's so let's set the rotation is positive. Okay, so the thumb points in the joint axis and positive rotations are this way. Okay, the usual right-hand rule. Okay, so let's do that. Do that. Okay, so this is my z-axis. And it's frame I minus 1, so z sub I minus 1. Okay, now my x-axis is this way. Okay, and then once I have my x and z-axis, the y-axis is defined automatically, right? X cross y equals z, so y is going to be, I don't know, somewhere like that, maybe. Y sub I minus 1. Okay? So that's my link frame I minus 1. Okay? Notice that it's not necessarily attached to a physical link. Okay? Okay. But the thing to remember is that if this joint turns, okay, this joint turns, this frame also moves. Okay? So as the joint moves, so does this frame. Okay? Okay, same thing here. So to assign the frame for this axis, we need to find, okay, joint axis I plus 1. Draw the mutually perpendicular line. So maybe that over here. Okay, and then our z-axis is that way. Our x-axis is this way. And our y would point somewhere in that direction. Okay? All right, so these are the rules that Denevitt and Hartenberg first proposed. Okay, so let's say we all agree on these rules. Okay. Now, how do we describe the transformation from this frame to this frame? Okay, in other words, what's that? Okay, all right, so let's figure that one out now. Okay. All right, so to do that, I'm going to draw some intermediate frames. Okay. So first thing I'm going to do is I'm going to draw a line that's parallel to this axis, but over here. Okay, so let me draw this line. Okay. All right, so this line and this line are parallel. Okay. All right, and then I'm going to draw another frame. Here's my red pen, or red chalk. This time the z-axis of this frame is going to be along this dotted line. Okay, and the x-axis is going to be in the same direction. So the y-axis will have shifted, right? So let's call this, that's my z direction. This is still my x direction. My y direction will now have shifted maybe over there. Okay. Okay, let's call this frame A. Let's see, what letter should we use? Okay, yeah, call it frame A. Okay. Now I'm going to slide this frame over here. Keep the same orientation, okay, but just slide it over. So now it'll be that, that, that. So here's my x, y, z. So let's call this frame B. Okay. Okay, now I'm going to slide this frame up. Slide it up. So Okay, so here's, correct this drawing a little bit. So here's my x direction, here's my z direction, here's my y direction. So this is my frame C here. Okay, so let's say I have 5 frames. Okay, the first frame is frame I minus 1. This yellow frame here is frame I. Okay, and in between I have frames A, frame B, and frame C. Okay. All right. So let's get rid of the question mark. I'm going to write this. So I've broken it up even further. So this is going to be T I minus 1A times T A to B times T B to C times T C to I. Okay? So that's my strategy. All right, so what's T I minus 1A? So I'm standing at frame I minus 1. I want to write down the orientation of frame A. And what do you notice? The x direction is the same for both frame A and frame I minus 1. Okay? X direction is the same. The y and z are different. So what we've done is we've rotated, right, around axis x. By what angle? What's the angle of rotation? Well, it's this angle here, right? So we need to know that angle. So let's give it a name, or let's assign a variable. Let's call it alpha. So this is joint I minus 1. So this angle is alpha I minus 1. Okay? So this is a rotation around the x-axis by angle alpha I minus 1. Okay, and you know what this form looks like, so I'm not going to bother to write it out. Okay, now TAB. So now we want to go from A to B. So this one, what do you think? The orientation is the same. Okay? But now what? We've moved in the x direction by how much? By this length. By this length. Okay? So we need to know the length. So let's call it A sub I. AI minus 1, sorry, I minus 1. Okay, so this is a translation in the x direction by distance AI minus 1. Okay, next, we want to go from B to C. So what is that? B to C, we're moving in the z direction by some amount. What is that distance? Well, we need a name. So let's say this is d sub I. Okay, so we're translating along the z-axis by a distance d sub I. So now we switch from I minus 1 to I. Okay, last, not least, we need TC to I. So I'm at frame C. I want to go to frame I. What is that? Frame C is the red frame. Frame I is this yellow frame. So we're rotating around the z-axis. If we rotate frame C around the z-axis by, we need this angle, right? We need, so these lines are parallel. Okay, so we need this angle. Let's call it theta I. Okay, so last thing we need is rotation around the z-axis by angle theta I. Okay. All right, so if we agree on this method for assigning link frames, okay, then ti minus 1I is going to look like this. Okay. All right. So that's it. Well, okay, few details we still have to resolve, all right? But this is the basic idea. Okay. All right. Now, so here's the plan. Rather than give you a whole list of rules, okay, on what to do for these various cases, let's go through examples. Okay. Let's go through examples. And like I said, this is audience participation day. Okay, so we'll go through these examples, figure out what needs to be done to fix these, to make sure that these rules can be assigned in a uniform and consistent way. Okay. All right. So start with So let's start with a 3-revolute joint example. So there's one. Okay, so there's my chain. And we'll put the hand over here somewhere. Okay, so and let's say that this joint is rigidly attached to the wall. Okay, so I want to write down the forward kinematics for this robot. So let's see. Well, I need to assign hand frames and end effector frames. And if you notice, we haven't really talked about that here, right? How to assign the fixed frame, how to assign the hand frame. So if there are no rules, that means we can do what we want. So I'll just pick some arbitrary frame. Okay. So let me. Okay, so let me just pick, say, X, Y, Z, okay, to be my fixed frame. And my hand frame, I'll do the same. Okay, just X, Y, Z here. X, Y, Z. Okay, so here's my. Here is my fixed frame. Call it 0. Okay, now let's get to work. So what do we have to do? We first have to identify the joint axes. Okay, so here's joint axis 1, joint axis 2, joint axis 3. Okay, so which way is positive rotation defined? Well, let's say that's given to us. So that way, that way, that way. Okay? All right. Okay, so we found the joint axes. Next, what do? Let's find this line. Okay? The mutually perpendicular line between the joint axes. Okay, so I look at joint axis 1, joint axis 2. So what? It's this line right there. Okay, and then over here, joint axis 2, joint axis 3. So that would be that line. Okay, and joint axis 3, joint axis, oh, no joint axis 4. Okay, no axis out here. Okay, so all right, so let's keep a table of sort of issues here. Okay, how do I assign the frame for the last link? Okay, last link frame. Okay, what do we do? Okay, so we'll come back to that. Okay, so that's on our list of things to worry about later. Okay, so so now let's assign link frames. So frame 1. Frame 1. The z-axis is this way. Okay, remember it's always points in the joint axis direction. X-axis is which way? Is this way. Here's my x. Oops. Here's my z. So my y is right into the board. Okay, so there's frame 1. There's frame 1. Okay, frame 2. Let's see. Here's the origin of frame 2. Z-axis points in the joint axis direction. That way, so that's my z. X-axis points in the link direction, or the mutual perpendicular line direction, so that's x. So x cross y has to be z, so y means y has to be that way. Okay, so that's my frame 2. Okay, frame 3. Uh-oh. Not sure what to do here. Okay, not sure what to do here. So what we could do is we can think of this being the frame for, okay, the joint axis, an imaginary joint axis out here. Okay. So in which case, right, we could put a frame over here, the origin of the frame there. The z-axis is that way. Okay. Now the x-axis direction. What do? We have to find the joint axis out here, so that would be the z direction. Okay. And then we draw the line that is perpendicular to both joint axes. Okay, but the z direction intersects this line. Okay, and I don't want to deal with that right now, so let me change this then. Okay, so I'll just call this my z direction, okay? And this will be my x direction, and this will be my y direction. Okay, all right. So we change the hand frame, okay, to make life a little bit easier for us. Okay, so if I imagine this to be joint axis, this imaginary joint axis 4, okay, then I draw the line from here to here. Okay, so that means my x direction is this way. Right, x. Okay, that's my x direction. And then my y direction would be over there. All right, so it's a little bit cluttered here. It's my z, and this is my y. Okay? Okay, so I think it's okay now, right? Okay, so last link frame, what we're going to do is we're just going to use the hand frame. Okay? Okay, so are we ready now? Are we ready to write down the parameters? So let's get rid of this for now. So let's see, what parameters do we need? let's see, we need alpha, we need A, we need D, and we need theta. Okay, these 4 parameters. Okay, so these alpha, A, D, theta. Okay, so these are the Danovet-Hartenberg parameters. Okay, so these are the DH parameters. Okay, and these parameters describe the structure of the robot, right? Okay, so what we normally do is we make a table. So let's make a table. So here's I. I goes from 1 to 3. And then we have the values alpha, A, D, theta. Okay, so we make this 3 by 4 table. Okay, now we're going to fill in the table. Okay, so let's go here. So to fill in this first row, we have to imagine that we're going from frame 0 to frame 1. Okay, going from frame 0 to frame 1. Okay, so let's see. Frame 0 is XYZ. Frame 1 is XYZ. Okay. So in the first step, what we do is we rotate around the x-axis. Okay, rotate around the x-axis. What? To make sure that the z-axes are lined up. Okay, so here we are. Right, rotate around the x-axis by angle alpha. Okay, if we do that, then joint axis I minus 1 and joint axis I are lined up. Okay. Okay, so let's see. Here's Z. Here's Z. They point in the same direction. Okay? So we don't need to rotate around the x-axis, right? So this is 0. That's 0. Okay? Next, what do? Next, we translate in the x direction. Okay, we move in the x direction. Keep the same orientation. So here's x. All right, do it this way. Here's the x direction. We move in the x direction. Okay, so we move in the x direction by how much? We want to go from here to frame 1. Okay, so do we need to move in the x direction to go from here to here? Okay, so yes. Okay, so all right, let's do a vote. How many think yes? Raise your hand. How many think no? Raise your hand. Okay, the no's have it. Overwhelming majority. 0. Okay. And then the next step, we move in the z direction. By how much? Z direction. 0. Okay, and finally, we rotate around the z-axis by how much? Okay, somebody said 90 degrees. Yes, 90 degrees. Okay, so let's see. So all we're doing here is we're just rotating around the z-axis by 90 degrees. And that should get us from here to here. Or does it? Or does it? Does it? If I rotate this by 90 degrees, okay, orientation is the same, but this frame is here, this frame is here. Okay? Something is wrong. Okay, I want to move this frame from here to here using those 4 operations: rotation, translation, translation, rotation, right? But all I can do is just rotate. I need to get over here somehow, but it's not happening. Okay, what's wrong? Or is something wrong? Did we do something wrong? Yeah, it looks like we cannot just choose the fixed frame arbitrarily. Okay, we can't do that. Okay, so this doesn't work. We can't choose it this way. We can't translate in the y direction. It's impossible. Okay, so this doesn't work. Bad choice. Bad choice. Okay. So what does work? Well, it's pretty clear that translation in the y direction doesn't work. Okay. Rotations around the y direction are also not possible. Okay, so we have to choose the fixed frame in a way such that it works. Okay, so easiest way to make it work is pick the same frame as frame 1. Okay. So x, y, z. So pick it to be the same frame. Okay. So there's the first lesson we learned. Okay. Wow, we can't just pick any frame. It doesn't work. So if we now pick this 0 and the 1 frame to be the same, then this is what? This is what? Now, you have to remember something. If we rotate theta 1, this frame also rotates. Okay? So theta 1 is arbitrary. Theta 1 is arbitrary here. So if we rotate theta 1, frame 1 rotates. Okay? So actually this parameter here is a variable. It's theta 1. It's the joint variable. Okay? So that's the first row. Okay? All right. So I think now's a good time to sort of come back to this and say, all right, so in order to describe the transformation from frame I minus 1 to frame I, I'm going to try to do it with 4 parameters. 1, 2, 3, 4. 1, 2, 3, 4, right? Okay, so we spent several hours saying how many parameters do we need to describe the position and orientation of this frame with respect to this frame. How many do we need? How many do we need? Okay, not a trick question. How many do we need? 12? 64? What is it? Well, how many do we need? How many coordinates or parameters do we need to describe this frame's position and orientation relative to this frame? What do you think? Okay, I hear it. I hear it. How many? 6. 6. Right? 6. And we're trying to do it with 4. So that's impossible, right? So that's why we run into that problem there. We cannot choose the frame arbitrarily. Okay? We're trying to achieve the impossible with 4 parameters. Okay? So that's why we had this problem here. That's why we had this problem. Okay? In order to make this work, we have to choose the frames in the right way. Okay? Okay, so there you go. Next row. Now let's go from frame 1 to frame 2. Okay, so first thing, rotate in the x direction by how much? Frame 1, frame 2. So let's line up the z-axis of frame 1 with the z-axis of frame 2. So rotate by 90 degrees. Okay, so that lines up this z-axis with this z-axis. Okay, and then we slide from here to here, slide over in the x direction by how much? Well, by this much. Okay, so let's call that link L1, say. Okay, so L1. Okay, so we slid over, and then next, now we want to move in the z direction. Okay, so let's do it again. So we rotate around the x-axis. Okay, so the z-axis here points this way. Now we slide in the x direction over here. Now I want to rotate in the z direction, or actually translate in the z direction. Do we? No. That's 0. Okay, finally, rotation around the z-axis. Let's see, by how much? So y is pointing up, right? Slid over. What is, so it's plus minus, or it's plus 90 or minus 90 degrees with theta. What is it? What is it? It's minus 90 degrees, I think, right? So this is theta 2 minus 90. Okay. Okay. Third row. Let's now go from frame 2 to frame 3. Let's see. First, rotate around the x-axis by how much? How much? Okay, so our audience participation day is not going very well so far. How much do we rotate around the z-axis? 90도? 90 or minus 90? Plus or minus. So your chances are 50-50. Minus. Okay, minus 90. Okay, and then next we move in the x direction, slide in the x direction by how much? Some link length, okay, L2. And then we slide in the z direction by how much? Nothing. Okay, and then finally here, do we need to do anything here? Theta 3, do we need to add like plus minus 90 degrees here? I don't think so. Yeah, just theta 3. Okay, there it is. There it is. Okay, so these are your DH parameters. Okay. All right, let's keep that picture. All right, so now okay, so now what if let's see, z-axis is what if I had another joint down here? Okay. Okay. So these joints are parallel. Okay. So in this case, we have to, right, find a line connecting these two axes that's perpendicular. Okay. But there are lots of them. In fact, there's an infinite number of them, right? Okay. These lines are all so parallel. Okay. So in this case, we also need some, maybe we need some set of rules. Okay. Any will work. Any will work. But rather than call it a rule, let's just call it a suggestion or a guideline. Okay. Pick the one that's most convenient. Okay. So in this case, probably would be this, right? Okay. So this is probably the most convenient. Okay, so choose that. Okay, right. So we want to live in a society where we have just enough rules so that everything works, but no more. Okay, so same way here. So let's just call it a guideline. Okay, so we have a chance to derive the DH parameters for various spatial chains in the discussion section this week. Okay, but in the meantime, you might want to go home and look at some of the examples in the text. Okay, let's stop here.